This time Manas sir. Today we are going to discuss a topic of electrochemistry. The topic name is Nernst equation. Nernst equation we are going to discuss today. The first point is that why we are using Nernst equation. This Nernst equation we are using to calculate electrode potential. Yes, it is used to calculate electrode potential. Until my next lecture, what we discussed that electrode potential is what? So what I'm talking about is electrode potential. This electrode potential is, which we find as E, it is basically the difference of potential in between two electrodes. In between two electrodes. So, in Nernst equation, what we are going to discuss is that how we calculate electrode potential in two situations. One is called the standard conditions, and the another one is called the non-standard conditions. It is very easy, dear students, it is very easy to calculate electrode potential in a standard condition. So now I am talking about that standard conditions. Standard conditions. These standard conditions are what? When the concentration of given electrolytic solution is 1 molar and temperature is 298 Kelvin. So under these circumstances, electrode potential calculation is very easy. Then why we are using this Nernst equation? So to calculate the electrode potential in the non-standard conditions, we are going to use this Nernst equation. So I can write here to calculate electrode potential in non-standard condition, we are using Nernst equation. We are using Nernst equation. This is you can say the beginning of the topic, that under this condition we are going to use this Nernst equation. So what is Nernst equation? How it is derived? Let me discuss about it. Before that, in a cell, whenever we have a cell, then some work is there, some energy is there. In thermodynamics, we discussed that this del G. I think you guys are most aware about this del G. This del G is what gives free energy. This del G is what gives free energy. So this, with the help of this gives free energy, we calculate Nernst equation. And I think you guys are aware that whatever the energy we have in the system, it is used is what to do the useful work. I repeat, to do the useful work. So this work or this energy is going to use to calculate the Nernst equation. Now how it is? Let's see about it. As we know, del G is, you can say, gives free energy in non-standard condition. Del G naught is Gibbs free energy in standard condition. And dear students, I think you must aware the relationship between this del G and del G naught, which is del G is equal to del G naught plus 2.303 RT log Q. Here the Q is the reaction quotient for the given reversible reaction. For the cell, we know that the reactions are reversible reaction. So this Q is what? A reaction quotient. Now, what is this del G? As I told you, this del G is the useful work in a non-standard conditions. So it is NFE cell. I am repeating this. N is the number of electrons which are exchanged during the cell reaction. F, we know that it is a Faraday charge. E cell is the cell potential which we are going to use. What is this del G naught? This del G naught is minus NF E naught cell. So whenever I am saying del G naught, that means the Gibbs free energy in terms of the standard conditions, dear students, and del G is what? It is a Gibbs free energy in terms of non-standard condition. And I think you are aware that this R is gas constant, T is temperature, which you put in the Kelvin unit, and this Q is right now the reaction quotient. So any doubt till here? And log Q. Now from here, this R is what? As I told, it is a molar gas constant. So it has some specific value as we know. What is this T? T is, as I told, right now I'm putting again, is 298 Kelvin. F, we know it is a Faraday charge which is equal to 96,500 coulomb. N is variable, which is number of electron exchange during the cell reaction. So if I put down this value, then again I am writing this E cell is equal to E naught cell minus 0.059. Wait a minute. This 0.059 upon Q. What is this 0.059, sir? This is 2.303 RT upon F. When I solve this equation, 2.303 RT upon F, then I got a value of 0.059. This is the standard value. Because everything is fixed. 2.303 is a numerical data, R is again a numerical data, T is a temperature in terms of Kelvin, which is also constant, F is also a constant. So this. So now this is called a Nernst equation. This is called a Nernst equation. This is the equation from where I calculate the cell potential. This is the concept that how you calculate a cell potential during the cell reaction. Now, the point is that how we are using this cell equation. So there are certain things. One is what? The first thing is that we use this equation for half cell. Second, we use this equation for complete cell. Now in a complete cell there are two situations. One is that when number of electron exchange same in both half, same in both half, and another one when number of electron exchange are differ in both. So, dear students, that we have to keep in mind that when which kind of equation is used. So, the first two the conditions are only for half cell, and the second is for the complete cell. In the complete cell, there are again two situations. One, when the exchange of electron between the oxidation half and the reduction half is same, and the another one when the exchange of electron in the oxidation half and the reduction half are different. And there is a third or one more condition, the third, which is known as, we use this equation in a concentration cell. We use this equation in concentration cell. So let's discuss one by one that what is a half cell equation, what is a complete cell equation. So before that, please note it down, and if you have any doubt, then please ask. This is the equation. This one is the equation from where we are calculate a cell potential for the half cell, for the complete cell, and for the concentration cell. I hope you write it down. So let's discuss that for the half cell. What is a half cell basically? See, those cells in which a metal electrode is dipped in its own solution. What I am saying? Those cells in which metal electrode is dipped in its own solution. For example, when Zn rod dipped in ZnSO4 solution. So if I want to calculate the electrode potential of such cell in which Zn rod is dipped in the Zn4 solution, then how I calculate with the help of this equation, which is known as E is equal to E naught cell minus 0.059 upon N log Q. Now here the interesting point is that what is this Q? What is this Q? This Q is reaction quotient, as I told you. So let's do an example of that. Calculate cell potential of 0.01 molar zinc sulfate containing cell, and it is given to us that E naught for Zn plus 2 to Zn is equal to 0.76 volt. So now I am discussing the entire concept in terms of a numerical, that how we are using this equation when a numerical is given. So here it is like this. So what is given to us? The solution is E naught is given to me, which is equal to 0.76 volt, and the concentration of cell is given to me, 0.02 molar. So I am using this equation. It is very easy. Yes, it is E cell is equal to 0.76. I am just putting the values. E naught is 0.76 minus 0.059 upon N. Now, what is this N? As I told, N is number of electron exchange. So, whenever this zinc sulfate solution is decomposed, what we obtain is Zn plus 2 and SO4 minus 2. I think you guys are aware of that. And then this Zn plus 2, whenever it reduces, it converts into Zn. So here, the number of electron exchange during the reaction is 2. And that's what I told you. What is this N? N is number of electron exchange during the reaction. So in place of N, I have to write 2. Log. What is this Q? Q is reaction quotient. And reaction quotient is what? Oxidation half on reduction raised to power stoichiometric coefficient. Oxidation half upon reduction raised to power stoichiometric coefficient. As far as this numerator is concerned, so this 0.76 minus 0.059 by 2 log. Now, which is going to reduce in this equation? Zn plus 2. And what is the concentration of that solution? It is given as 0.01. Here, it is in a solid phase. This one is in aqueous phase. And we know that everything which is in solid phase, we say its concentration is 1, or I can say 1 molar. So this is equal to what? 1 upon 0.01. Because I am explaining you first time, that's why it takes a little bit time. Otherwise, it is really very easy to calculate. This is 0.76 minus 0.059 by 2, it is 0.0295 log 1 upon 0.01 is nothing but log 100. And when I solve this, then this is 0.76 minus 0.0295. Log 100 is 2 log 10. And log 10 is, this is 0.76 minus 0.059. That's how we calculate cell potential in case of a half cell. Yes, this is the concept that how you calculate the cell potential in case of a half cell. Half cell is a cell in which a metal electrode is dipped in its own solution. There are so many things which we have to discuss. Another part is that what is a complete cell. So before that, please have a look at how we are using this equation. Here it is given that E naught for the metal is 0.76. This is reduction potential, and we know that what is reduction potential. Before this lecture, we have already discussed the meaning of oxidation potential and reduction potential. This is how we calculate a half cell equation.